This lecture we're going to start talking about the postulates of quantum mechanics. Okay, postulates. What's a postulate? Assumption. Okay, so the basic ideas. So a postulate is something that you cannot prove. Okay, that's the most basic of all the assumptions. So if you can't prove it anymore, you just assume it's true. And for as long as you don't encounter any contradictions, you accept it. Okay? So, what are the postulates of quantum mechanics? There's several. The very first postulate, postulate number one, says that for any system, okay, there is a function which we represent by the Greek letter psi. So that's the Greek letter psi, which describes the state of the system. All accessible information about the system can be obtained from psi. So anything you want to know about the system, if it's available, you can find it in psi. Okay, so in other words, if you know someone who's a know-it-all and you want to give him a nice gift, give him a shirt that has psi printed on the shirt. Okay, so psi gives you all accessible information about a system. So psi is called the state function or the state wave function, or just we simply say the wave function. So it depends on Q and T. What's Q and T? Q here represents the coordinates of each and every particle in the system. And T would be the time. Okay, so psi then, you can imagine psi for something like a sample, a macroscopic sample of matter is going to be a huge function. It's a function of the coordinate of each and every electron and nucleus in your particle and time. Okay, so for our purposes, we're going to treat the nucleus of an atom as just one particle. Okay, so we're going to take all the neutrons and the protons all together as just one particle. So the nucleus of an atom will be taken, we're just going to deal with it as just one particle. Then each electron is treated also as one particle. Okay, so upon how many coordinates does the state function for a helium atom depend? 1, 2, 3, 4, or 5. Helium atom has a nucleus, right, of 2 protons plus neutrons, right? Which can vary depending on what isotope you're dealing with, right? And so that's counted as one particle. How many electrons does our helium atom have? 2 electrons. So how many particles do we have? 3 particles. So that's the nucleus plus 2 electrons. Okay, so it will depend on 3 sets of coordinates. Consider a one-particle system. Let's say you're just dealing with a system of just one particle, and that particle happens to just be constrained to move in one dimension, just along the x-axis. How many variables, upon how many variables would our state function depend on? What would you need to locate the particle? Just one number, right? Because it's just confined to the x-axis. So psi will just be a function of x and time. So how many variables then? 2 variables. Consider 2 particles constrained to move in a plane, the xy plane. So no 3-dimensional movement, just on a plane, flat surface. How many variables does the state function depend on? So let's call those 2 particles particle 1 and particle number 2. So how would you locate particle 1? You're going to need 2 variables, right? So you need x1 and y1. And to locate particle 2, you're going to need x2 and y2. And then time. So it depends on how many variables? 5.